In this lesson, we're looking at the idea of literal equations and how to solve for specific variables within them. A literal equation just really is a formula, like one you would see in a chemistry or a physics class type deal. And what we're going to try to do in like this problem, we have E equals mc squared. E is already by itself. But what if we want to know m? What if we're given E and we're given C, but we don't know m, what the mass is? So we want to find out how to get things by itself. Same thing here. Maybe I know A, maybe I know C. How do I get one of those by itself? That's our goal for today. So, to solve for a specific variable, let's say we're solving here for M. Well, what I like to do, I like kind of marking, here's M. Well, M, the only thing on the side with M, because I want to get M by itself, is this C squared. Well, they're attached by multiplication, so to undo it, to get rid of a C squared, I would need to divide by C squared. But to do that, if I do it on one side, I better do it on the other side as well. So, those would cancel out. E and C squared, can't do anything with that. So I just write it E over C squared is equal to M, because that can't simplify at all. And now I have M by itself, which is all I was trying to do. Same thing in this one. PV equals nRT, same chemistry formula here. To get N by itself, again, you have an R and a T over here on the same side. They're attached all by multiplication, so I will undo that by dividing both sides by R and T, which gives me PV over RT is equal to N, and that's how I get N by itself. Let's look at a couple more. Okay, in this one, we're getting a little more complicated one, a couple multi-step problems. To solve this first one for X, well again, here's X. It's attached with M by multiplication. First, though, we need to get rid of any other term on that side. So I have this plus B. I need to get rid of it first. I have a plus B. To get rid of it, I would do minus B. And the reason I'm subtracting and not dividing is because these terms are combined through addition. So I can't combine a y and a b, so I just leave it y minus b. And all I had left on this side was the mx because the b's canceled out. Now, from here, what I'll need to do is to, excuse me, get x by itself again. Well, now we're kind of like the problems from before. I have it attached to the m. It's attached by multiplication, so I need to divide both sides by m. So y minus b over m will equal x. See if anything simplifies. In this case, no, they do not. Okay, this next one, solve this one for x. Same thing. Here's your x. Here's another term on that side. I need to get rid of all those other extra terms. So I'm going to subtract 4y first to begin with. So when I do that, it's going to leave me 2x on the left, 7 minus 4y on the right. Again, I can't do anything with that. I can't change it around. I can't combine any like terms or anything. Okay, and again, I have 2x to get rid of that. It's attached by multiplication. I better divide both sides by 2. So x will equal 7 minus 4y divided by 2. It's fine. You can leave it just like that. One of the things we talk about sometimes is the idea of, I kind of call them a heart problem because you can kind of make a little heart here by splitting up a fraction. You would write that as 7 over 2 minus 4y over 2. And then that could simplify. This would become just 2y because I could simplify that fraction. So if you wrote it just like this, that's great. If you decide to take it and go a little bit further and break it up, then that's cool as well. Okay, at this point, I would say pause the video, give this last guy down here a try, and see if you can get the right answer. Alright, let's check and see how you did. We need to solve for x. Again, here's your x right here. First, I need to get rid of all other terms. So get rid of a 4z. I get rid of that by subtraction because they're subtracting on both sides, or because they're combined by addition, therefore I do subtract on both sides. So 6xy will equal 100z minus 4z. Well, those are like terms. They're the same thing, so I can just write that as 96z. From there now, to get x by itself, I'm going to need to divide by 6, because there's 6 there, and by y, because there's an extra y. They're all attached by multiplication, that's why I'm dividing. If I do that on the left side, I better do it on the right side as well. So my answer will be that y equals 96z over 6y. But I better check. Can I do 96 divided by 6? Or can I simplify that at all? Oh yes, in fact I can. 96 divided by 6 equals 16. So I'd have 16 in z up top and y on bottom. That's what, not y equals, that's what x equals. So that would be your final answer. There you have it. Just make sure you go one step at a time, remove all other terms first, and then divide by whatever is attached to your x, and make sure you have just a single x by itself.